Designing the mixing of base coarse material involves determining the right combination of aggregates, both coarse and fine, and other components to meet strength, gradation, and compaction requirements. The design process follows established engineering practices and testing to ensure that the base course will provide adequate support for the pavement structure. Here's a step-by-step guide on how to design the mixing of base course material. 1. Determine project requirements. Traffic load. Calculate the anticipated traffic volume and load that the road will carry. This includes determining whether the road is for light or heavy vehicles. Subgrade conditions. Assess the soil properties of the subgrade, as it influences the base course design. Weak subgrades may require a stronger base. Environmental conditions. Consider factors like freeze-thaw cycles, drainage, and water table levels. 2. Select base course materials. Aggregate type. Choose the appropriate base course material, which could be crushed stone, gravel, recycled concrete, recycled asphalt pavement wrap. Ensure the material meets local specifications and standards, e.g., ASTM, ASHTO, or local authorities. 3. Determine gradation. Use local or project-specific specifications to select target gradation. Typical gradation requirements ensure adequate compaction, good drainage, sufficient stability. A well-graded mix usually has a combination of larger particles for strength and smaller particles for filling voids, promoting compaction. Gradation testing. Run a sieve analysis of the available aggregate material to check its particle size distribution. Example gradation specification. ASHTO. Coarse aggregate, 20 mm to 5 mm, 60 to 70%. Fine aggregate, sand, less than 5 mm, 30 to 40%. The mix should generally follow a gradation curve that maximizes compaction and minimizes voids. 4. Laboratory testing. Conduct tests to assess the performance of the mix. Proctor compaction test determines the optimal moisture content and maximum dry density for compaction. This is crucial to achieve the best mechanical properties. California Bearing Ratio, CBR, measures the load-bearing capacity of the material, ensuring the base course meets strength requirements. Resilient Modulus Test tests the stiffness of the material, indicating its ability to withstand traffic loads. 5. Mix design adjustments. Moisture control. Based on the Proctor compaction test, determine the required moisture content. Usually, water is added during construction to reach optimal compaction. Proportioning materials. If your initial material does not meet gradation requirements, adjust by mixing additional coarse or fine aggregates to meet the target gradation curve. Additives. If needed, additives such as lime, cement, or fly ash can be introduced to stabilize the base course, especially in cases of weak materials. 6. Trial mix. Create trial mixes in the lab to test the performance of different aggregate combinations and moisture contents. Verify that the mix meets the strength, compaction, and gradation specifications. Adjust the proportion of fine and coarse aggregates if the material does not meet project specifications. 7. Field testing. Once the trial mix meets the specifications, produce small test sections in the field to confirm that the material behaves as expected under real construction conditions. Perform field compaction testing using a nuclear density gauge or sand cone test to ensure that the mix compacts well and achieves the required density. 8. Determine base course thickness. The thickness of the base course depends on the subgrade strength and the traffic loads. Use engineering design guides such as ASHTO's Pavement Design Guide to calculate the necessary thickness. In typical roadways, base course thickness might range from 150 mm, 6 inches, to 300 mm, 12 inches, but this varies depending on the project. 9. Mix refinement if necessary. If field tests show the mix isn't performing as expected, e.g., poor compaction or strength, return to the lab to refine the aggregate blend or adjust the moisture content. Adjustments may involve altering the aggregate gradation, moisture content, or adding stabilizing agents. 10. Finalize and document mix design. Once the mix design is finalized and meets all project specifications, document the final proportions, gradation, compaction requirements, and moisture content. Include field testing procedures to ensure compliance during construction. Tools and software. Pavement design software like PavementMe Design, formerly AASHTOware, can assist in modeling and optimizing the mix design and pavement structure based on inputs like traffic load and material properties. Example of proportions. For a base coarse mix, a combination might be 70% coarse aggregate, 20 mm to 5 mm crushed stone, 30% fine aggregate, sand and fines. Water added to achieve optimal moisture content for compaction, typically 5 to 8%. By following these steps, the mixing of base coarse material can be designed to meet the required specifications for strength, compaction, and durability.